Let's get ready to go. Equations and functions. Let's take a look and see what that does. So let's get some vocabulary out of the way today again. Let's start there so we know what we're talking about. We know what we're sharing with each other. All right, so think about this. If we see the word linear function, so function we know is one input gets you one output. That's that part. But a linear function, what do you see in the word linear? You can see it right here. You can see the word line. So that means it's going to create a function or equation that creates and graphs forms when graphs forms a straight line. There we go. An equation / function that when graphed forms a very straight line. Okay, so it has that exact same path every time. So if I'm graphing it on a coordinate plane, it would look something like this. It could also look something like this. It could look a lot of different ways. It could look any different structure I want it to look, but as long as it stays a straight line and not some random curve, that's what we're looking for. So that's what a linear function is. Now, let's kind of build this in this idea of x and y input. We talked to yesterday about a rule for this table, for the function shown. A rule to create this. And you guys created these tables yesterday. Okay? And I would have given it to you something different, looking something like this, where it was x and y here. And then I had you create the rule and write the rule here. So if your input is 1, your output is 9. And we were starting this at the end of class in 18. You would go, okay, what happened to 1 to make it 9, 2 to make it 18, and so on and so forth. So if that's our case, let's think about this, just a different way to look at it. The input is 1. The output gets me 9. So what did I do to get that? Okay, I could either add 8 or multiply by 9. So let's see if add 8 works. If I add 8 to 2, that gives me 10, so it's not add 8. If I multiply by 9, it gets me 18, and that follows that rule. So when we write it as an equation, we're going to write y, the output, is equal to 9 times the input. So y equals 9x. Go ahead and take a look at this function table and see what you can find for this. All right, you guys found this. You can see that while you could add 11 or multiply by 12, the only one that follows is y equals 12 times x. Okay? All right, now, one of the things we can do with this is now graph. We can say, okay, we can make ourselves our own little function table here. X and y, if my input is 0, what's 0 times 2? 0. If we make our same here, we go, okay, what's 1 times 2? That's 2. 2 times 2 is 4. 3 times 2 would be 6. All right, so let's graph 1 times 1. Okay, that's here. 1 over 2 up, 2 over 4 up, and then 3 over 6, that would be 6 right here. I've created myself a linear function, okay, that I could use to figure out future or even misnumbered pieces. So like, oh, half of 2.5 would get me 5. And that follows pretty solidly with what our function looks like. If we plugged in a decimal 2.5, 2 and 5/10, n times 2 and gets 5, that would work. All right, now this one's a little different. Still create that simple function table, x and y, and go ahead and create that and graph that function on your paper. All right, so this one changes a little bit. You guys were right. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4, and 3 plus 2 is 5. So I can go, okay. Starts at 0 over 2 up, 1 over 3 up, 2 over 4 up, and 3 over 5 up. And I could keep going, but we always kind of go 1, 2, 3 as our chosen function numbers. And we've got our answer. We've got this function here as, that's our linear function. Well, now that I can create this, one of the things I can do is work my way around it. Martino constructed a graph shown. He shows the height of his cactus after several years of growth. Make a function table for the input-output tables. So we can do that as we take a look at it, okay? We can come over here and go, well, x is our x-axis down here. So I've got numbers at 1, 2, and 3. So 1, 2, and 3. His first year of growth, it was at 42 inches. That's my y. The second year of growth, it was at 44 inches. In my third year of growth, it was at 46 inches. So I'm not going to ask you guys to do this on this problem, but I want to kind of talk about how I could create an equation. If I think back here, if I was to take my line and say, okay, at 0 years of growth, well, we can't, it's harder to do with this because I can't go, okay, and work our problem. We've got to do a little bit more to it. So this is actually a two-step equation function. If I was to write the relationship between it, it'd be something more difficult like this. It would look like y equals 2x plus 40. Okay, so the year he got it, it was already 40 inches tall. And then it kept growing 2 inches per year. I'm not going to ask you guys to create a formula like this yet. Maybe sometime in the future. Okay? All right, I want you guys to take a second and create that function table for this information. I'll make it a little bit bigger so you guys can see it a little better. See if I can get it just to be a wee bit bigger. There we go. Okay, so you've got your table. First thing you're going to do is go, okay, 1 over, it says at 25, 2 is 30, and 3 is 35. So we've got a pattern. So again, let's just talk really quickly and think about it now. I want you guys to think for a second. Pause the video and write what you think the equation might be based on the one we talked about before. I'm going to give you a hint. Continue your line back to 0, and that'll help you get started. All right, so y equals 5 times x plus, in this case, 20. That's our starting point. So apparently when she went to rent the canoe, you had to pay $20 just to get the rental. All right. So we kind of already did this earlier. So I kind of skipped ahead. But like we were talking about there, the key to this is extending the line or using that chart we created earlier. So if I say x and y, we know that it's 1 and 42, 2 and 44, 3 and 46. Now we create our line and write an equation. We know y is the answer. I can't just go 1 times 42. That doesn't work. So I've got 2 steps here. The way to make this work, like I was telling you in the last equation, extend your line back to 0. That's the thing about a linear equation. It's going to stay the same. So we're going to know that when he received his cactus at 0 years, it was already 40 inches tall. So we're going to say it starts at 40. And how does it change every time? Well, it went 2 bigger, 2 bigger, 2 bigger. So 2x plus 40. That's our equation. All right. We kind of already figured this one out. We said it was y equals, again, by extending that line, we said it was 5 times x plus 20. All right, so you guys have a really good start to the equations and the way to go. If you have questions, please reach out and we'll talk about it. But before you go, I want you to jump back to the very beginning and now take a look at these. Using words or symbols, describe the value in each term in the function and then find the value of the 20th term in the position. So pause the video and see what you come up with. All right, so now that you've had a chance to take a look at it, what happens between the two? Each time it's times 3 in this case. So we're going to say the term, so we'll say y equals 3 times n. There's my equation. Now if n is 3, if I want to know the 20th term, it'd be 3 times 20. So my 20th term would be 60. Over here, it would be plus 9. So y equals n plus 9. And you can use x, but it stated x in n as my position. So if I say 20 plus 9, the answer is 29 for the 20th term. Last one, you can see this one is actually times 9. So y equals 9x, or 9n, sorry. So 9 times 20 is 180. And our last one, find the rule for missing value, the sequence n. So this one's 1 and 1, 2 plus 3, 3 is 5. So this becomes a little more challenging. So if I know what happened here, it's added 2, right? So we would say y is equal to x plus 2. The previous term plus 2. If we take 1, or, now the other one, it's the previous term. And that's kind of how we look at it. So that's our basic idea for this sequence. All right, now you guys have taken a look at it. If you guys have any questions, feel free to reach out, and I'm happy to help you